Hello, my name is Scott Clark, co-founder and CEO of SigOpt. In this video, I'm going to show you how SigOpt can help you amplify your machine learning and AI models by optimally tuning them using our black box optimization platform. The SigOpt platform provides an ensemble of state-of-the-art Bayesian and global optimization algorithms via a simple software as a service API. SigOpt optimizes machine learning models like random forests, support vector machines, and gradient-boosted methods, as well as more sophisticated techniques like deep learning pipelines, proprietary risk models, and even complex backtesting and simulation pipelines. This enables data scientists and machine learning engineers to build better models with less trial and error by efficiently optimizing the tunable parameters of these models. This results in captured performance that may otherwise be left on the table by conventional techniques, while also reducing the time and cost for developing and optimizing new models. Every complex system has tunable parameters. A car has parameters like the gear ratio or fuel injection ratio that affect output like top speed. A machine learning or AI model has tunable hyperparameters that affect performance. This can be as simple as the number of trees in a random forest or the kernel of a support vector machine, or as complex as the learning rate in a gradient-boosted or deep learning method. In this simple TensorFlow example, we have constructed a 4-layer network to perform 2D binary classification. We are attempting to learn a surface that can differentiate blue and orange dots as seen in the figure to the right. Even this simple task and small network has 22 tunable hyperparameters, including traditional hyperparameters like learning rate and activation function, as well as regularization and architecture parameters, and feature transformation parameters. By tuning the parameters of this pipeline in unison, we can achieve much better results than tuning them independently. This extends to other AI and machine learning pipelines as well, which may incorporate many unsupervised and supervised learning techniques with tunable parameters. Domain expertise is incredibly important when developing new machine learning pipelines, which often undergo rigorous validation before being deployed into production. Often, the modeler needs to tune the hyperparameters and feature transformation parameters within their pipeline to optimize a performance metric and maximize business value of the model. This involves finding the best parameter and hyperparameter configurations for all the various knobs and levers within the system, and can have a significant impact on the end results. Traditionally, this is a very time-consuming and expensive trial and error-based process that relies on methods like grid, random, local, or an expert-intensive manual search. SigOpt uses a proven, peer-reviewed ensemble of Bayesian and global optimization algorithms to efficiently tune these models. First, SigOpt suggests parameter configurations to evaluate, which are then evaluated using a method like cross-validation, where an objective metric like AUC or F1 score is computed. This process is repeated either in parallel or serially. SigOpt's ensemble of optimization methods leverage the historical performance of previous configurations to optimally suggest new parameter configurations to evaluate. By efficiently trading off exploration, learning more information about the underlying parameters and response surface, and exploitation, leveraging that information to optimize the output metric, SigOpt is able to find better configurations exponentially faster than standard methods like an exhaustive grid search. All of this is accomplished by bolting our easy-to-integrate REST API onto your existing models and infrastructure. SigOpt's black box optimization algorithms require only high-level information about the parameters being tuned and how they performed, meaning sensitive information about your data and model stays private and secure. Additionally, the benefits captured by better tuning are additive with the work that you've already done on the model and data itself. In this specific example, we'll compare the relative trade-offs of different tuning strategies in a lone default classification pipeline using XGBoost, a popular gradient boosting library, and the Open Lending Club dataset. We'll tune the various hyperparameters of XGBoost and optimize the accuracy of AUC ROC. SigOpt was able to efficiently tune the pipeline, beating the standard methods of exhaustive grid search and randomized search, both in AUC and the cost to achieve that AUC. SigOpt found a model that had a 22% relative improvement in the metric when compared to the default XGBoost hyperparameters, as well as requiring 100 times fewer evaluations than the standard grid search approach. Because SigOpt is a black box optimization platform, it is agnostic to the underlying model being tuned and can be readily used to tune any machine learning or AI pipeline. All SigOpt requires is continuous, integer, or categorical parameters to tune, whether they are hyperparameters of a machine learning model or feature transformation parameters of an NLP or computer vision model, as well as a performance metric to optimize. SigOpt makes no assumptions about the underlying parameters or metric. It can even be a composite of many underlying metrics and does not need to be convex, continuous, differentiable, or even defined for all configurations. In this specific example, we'll compare the relative trade-offs of tuning different strategies in a computer vision classification pipeline using Google's TensorFlow on the SVHN image dataset. We'll tune the various hyperparameters of TensorFlow, as well as the feature transformation parameters related to the images themselves, to optimize the accuracy of the classifier. SigOpt beat the default hyperparameter configurations, as well as the standard randomized search approach in both accuracy and the cost to achieve that accuracy, by requiring fewer evaluations to reach the optimal configuration on a GPU cluster. SigOpt found a model that had 315% relative improvement in the metric when compared to the default TensorFlow parameters, while also requiring 88% fewer evaluations than the standard random search approach. SigOpt provides best-in-class performance. We've successfully deployed our solution at firms worldwide and rigorously compare our methods to standard and open-source alternatives at the top machine learning conferences. Our platform scales to any problem and provides features like native parallelism, multi-objective optimization, and more. Additionally, our black box optimization approach means that your proprietary data and models never leave your system, allowing you to leverage these powerful techniques on top of the infrastructure and tools you've already built. The SigOpt optimization platform integrates with any technology, and the intuitive dashboards shine a light on the otherwise opaque world of parameter tuning. Just plug our API in, tune your models, and your whole team benefits from the history, transparency, and analysis of the platform. SigOpt also allows you to tune any algorithm in parallel by acting as a distributed scheduler for parameter tuning. This allows you to tune traditionally serial models in parallel and achieve better results faster than otherwise possible, while also scaling across any number of independent models. SigOpt has been deployed successfully at some of the largest and most sophisticated firms and universities in the world. We've helped tune everything from algorithmic trading strategies to machine learning and AI pipelines and beyond. Contact us to set up an evaluation and unleash the power of Bayesian and global optimization on your models today.